Hi, this video is the third video for Lecture 3. In this video, I will explain annuity due and constant growth perpetuity. In the second video, we introduce the cash flow structure of annuity. It is ordinary annuity because the first payment is received one period in the future. Annuity due is different with ordinary annuity because the first payment is received immediately. There is no qualitative difference in calculating the present value of annuity due and the calculation for ordinary annuities. We can split the annuity due into two components. The first component is the immediate payment. The second component is an ordinary annuity with shorter periods. I will talk more details about annuity due. This graph provides an example of ordinary annuity. It is a 3-period ordinary annuity. The first payment will be 1 year after. Then you will receive the second payment 2 years after, and the final payment in 3 years. This graph is an annuity due of 3 periods. You will receive the first payment at year 0. Then 1 year after, you receive the second payment. 2 years after, you receive the final payment. We can split the annuity due into two components. The first component is an immediate payment. In this example, it will be $5 in year 0. The second component will be an ordinary annuity. In this example, it will be a 2-period ordinary annuity. For this 2-period ordinary annuity, you will receive the payment in year 1 and year 2. So together, these two cash flows, if you combine this immediate payment together with this ordinary annuity, you will get a 3-period annuity due. Now I want to talk about constant growth perpetuity. Constant growth perpetuity is very similar to perpetuity. Both of them has payments forever. But the constant growth perpetuity has the growing payment. For example, in a typical constant growth perpetuity, you receive cash flow payment for next period as $5. Then these cash flow payments will grow at a constant rate. Here I choose 0.01 as the growth rate. After n periods, the cash flow payment will be $5 multiplied by 1.01 to the power of n-1. Here is the timeline graph for this typical constant growth perpetuity. In next period, you receive $5. In 2 periods after, you receive $5 multiplied by 1.01. After 3 periods, you receive $5 multiplied by 1.01 to the power of 2. But how do we calculate the present value of constant growth perpetuity? In fact, we can make a small change to the discount rate, and then we can use our previous equation of perpetuity. The present value of growth perpetuity will be the cash payment over the discount rate minus the constant growth rate. In the example in previous slide, the cash payment is $5. The required discount rate is 5%. The constant growth rate is 1%. So then the present value of this growth perpetuity is $125. Remember this, the present value of a perpetuity with fixed payment $5 is $100. So the present value of growth perpetuity is higher than the present value of perpetuity. Why? Because in this constant growth perpetuity, you have payments growing, but in the typical perpetuity, you have fixed payment. I want to emphasize in how we choose the cash flow payment in using this present value of constant gross perpetuity. We need to use the cash flow in the next period. So next time when you calculate the present value for constant gross perpetuity, make sure you use the cash flow in the next period. Okay, now I want to provide more discussions about applying these calculation formulas. In previous slides, we analyzed problems where we know the cash flow, we know the discount rate, and we know the number of periods of these cash flows. Then we can use equations to calculate the future value and present value. What about other problems that we don't know the discount rate, or we don't know the payment, we don't know the number of periods? We can actually calculate these unknown variables if we know the present value and future value. Here is an example of calculating the discount rate. Suppose you know the future value of cash flow 5 years after, and you know its present value. So now you know the present value, the future value, the number of periods. We want to know the rate for this compounding calculation. We can change the previous equations to back out the discount rate. For this simple cash flow, the discount rate is equal to the future value over present value to the power of 1 over n minus 1. In previous example, we consider you can save $100 in the bank. After 5 years, you will receive $127.63. Now we can use this future value and the present value and the number of periods for this cash flow you need to back out the discount rate. You can verify the discount rate calculated based on this formula is 0.05. A similar question can be, you know the future value after 10 years, and you know the upfront payment as $1,000. Then you use this equation to back out the discount rate as 7.18%. If we are analyzing questions with multiple cash flows, then the question will be more challenging. Now you know the present value, the payment, and the cash flow structure. How to back out the discount rate for these multiple cash flows. First, we draw the timeline for these multiple cash flows. Then we write the equation for this present value. Here, for this typical annuity of 5 years, the present value equal to the payment multiplied by the present value annuity factor. So then we know the present value, the payment, the number of periods. We can use this equation to back out the discount rate. We use try and error to find the discount rate. After we calculated this discount rate, it will be an important concept for investment project valuation. We call this discount rate as internal rate of return. It gives us a good measure for how profitable this investment project will be. We will talk more details about this internal rate of return. Similar question can be related with payment calculation. For this 5-period annuity, if you know the present value, you know the discount rate, you know the periods you need to wait for this final payment of annuity, then we can back out the payment. A similar question can be how to back out the number of periods. If you know the payment, the present value, and the future value, then we use equations to back out the number of periods required for the present value and the future value. For this calculation, typically they are not feasible with algebra calculation. We need to use financial calculator or Excel spreadsheet to simplify this calculation process. I will go over more practice problems in the formal course, and I will upload the video related with online financial calculator to solve these kind of problems. In summary, for these lectures, we talk about how to calculate the present value of cash flow over time, and we provide analysis for perpetuity and annuity. And you can use this discount factor and present value annuity factor to have calculation quickly and easily. Thanks.